I thought I'd go through a quick review for chapter 3. So chapter 3, all we've been doing is unit 3 is just solving equations, or inequalities or equations, those two. So I want to go through and just do a quick example of each type to help you remember, and that will help you as you go through and work on the review assignment. So when you go to solve a linear equation is an equation that just involves x's. Right? There's no square roots or absolute values or inequalities. These are just really basic ones. So just a quick review of steps we follow when we solve linear equations. Number one is simplify both sides of the equation. So on this one, we could times through by that negative. So times through by that negative would be negative 5x minus 1 equals 3x minus 9. If they were like terms, we could combine them, anything we could do. But all I'm looking at is, look at this side of the equation, look at that side of the equation, simplify anything you can. I think that's it for this one. Okay, step number 2 is if you have variables on both sides, we want to eliminate the variables off one of the sides. So eliminate variables from one side. Okay, so on this one I have a choice. I can either get rid of the minus 5x by adding 5x or get rid of the 3x by subtracting 3x. It doesn't matter which one you do. Either one will give you the right answer. I'm going to add 5x, but if I add 5x to the left side, I have to add 5x to the right side. I end up with, that'd be 0, negative 5x plus 5x. So I end up with a negative 1 equals 8x minus 9. When you get to this point, right, step number 3 is you're just trying to get x by itself. Usually on those problems, we're going to add or subtract first and multiply or divide second. So I'm going to add 9. Ooh, sorry, shouldn't have been 8. Add 9 over and add 9 over. That would be 8 equals 8x, and negative 9 plus 9 is 0. Okay, last thing is divide. Divide by 8. 8 divided by 8 is 1, so 1x is x. 8 divided by 8 is 1, so there's my answer. Remember what it means to solve an equation. If you solve an equation, it means you find out what value of x makes it true. So let's double check and make sure this actually works. Negative 5 times 1 plus 1. The question is, does that really equal 3 times 1 minus 9? So let's work both these out. 5 times 1 is 5, 5 plus 1 is 6, but it's a negative on the outside, so it's negative 6. 3 times 1 is 3, 3 minus 9 is negative 6. Hey, negative 6 equals negative 6, so it worked. We got the right answer. I think most of us feel really confident about solving these. We're really good at them as a class. This is something we're all going to get right. We're pretty solid on these. Linear inequalities, they're a little bit different because instead of an equal sign, there's a greater than or less than or greater than or equal to or less than equal sign. But as far as solving, it's really the same thing. You're just trying to get x by itself. So you follow those same steps. You want to simplify both sides. Well, we can definitely simplify this side over here. That would be negative 3p. That changes to a minus 9. Okay, you get it, p by itself, so add 9. Add 9. So negative 3p, that would be 0 is greater than 18 plus 9 is 27. Now this is your only catch. When you divide both sides by a negative or multiply both sides by a negative, I'm going to divide both sides by a negative 3 right now. When that happens, the only catch to inequalities is you have to remember to switch the inequality sign. So since I divided both sides by negative 3, instead of being p is greater than, it's p is less than. Divide those two. That's my answer right there. Let's graph that answer. If I go to negative 9 is right there. There's no equal sign, so I'm going to do an open dot. P is less than negative 9, that means it's opening to the left. So you can write the answer with any inequality notation. You could graph the answer. We could also do interval notation. Remember with interval notation, you start from the left side. So how far to the left does it go? To negative infinity. And it includes everything between there and negative 9. So interval notation would be negative infinity to negative 9 with a parenthesis. We also did compound inequalities. Compound inequalities usually involve an or an and. A lot of times with an and problem, they're combined into one, like this one right here. Okay, so when you have these, you just solve each one separately. So I'm going to start this first one. Negative 5n is greater than or equal to negative 45. I'm just going to divide by negative 5. When I do that, I get n, and because I divided both sides by a negative, I have to flip the sign, is less than or equal to a negative 45 divided by negative 5 is 9. Or, on this one, I'm going to add the 10 over. And I get n is greater than, that's 0, greater than 10. That's my answer. I just write the answer with the inequality notation. But I need to graph it. It says n is less than or equal to 9. So I'm going to come over to 9. It's a closed dot this time because it's got the equal sign. It's less than. So it's going that way. And at 10, closed dot, it's greater than, so it's opening that direction. That's what my graph would look like. And that's what my answer would look like using inequality notation. We can also write out the interval notation like we just did. Start from the left side. It goes to negative infinity. And it goes until I get to negative 9 with a bracket. Because, sorry, not negative 9, I apologize, positive 9. With a bracket because 9's included. There's no answers between 9 and 10, but then at 10 it starts again. It includes everything from 10 to infinity. And then you put this union sign in between. That just means it includes both of them. So with OR, you just include both your answers. So look at the graph, whatever answer part's shaded in, that's all part of your answer. Okay, and questions can be written separately, or they can be written together like this. I want to go through an example that's written together like this. So I'm going to write it off to the side. I have 18 is less than or equal to 6k, which is less than or equal to 24. So you really have three parts. We have the 18, the 6k, and the 24. I still just want to get k by itself. 6 times k, I'm going to divide by 6. When I do that, I have to divide all three parts by 6. So the 18 has to be divided by 6, and so does the 24. So 18 divided by 6 is 3. That would be 1k or k. 24 divided by 6 is 4. So what that means, right, is k has to be bigger than 3, greater than 3, but it has to be less than 4. And they both have an equal sign. So we do a closed dot, and it's everywhere in between. The way you'd write that with interval notation is like this: bracket, 3, comma, 4, bracket. That's what the answer would look like. Those are compound inequalities. All right, the next thing we did was absolute value equations and inequalities. Let's start with the equations. I'll give you some steps on these. When you go to solve an absolute value equation, first thing is you're going to isolate the absolute value. Get the absolute value by itself. So isolate the absolute value. Get it by itself. So I want to get this part by itself right there. So think of the equation. The only thing on the same side that's not inside the absolute value is the 6. So I'm going to minus 6. It's a separate term. So we can do that. 6 minus 6 is 0. Absolute value of n plus 9 equals 14. Okay, when you get that, the next step is once the absolute value is by itself, is you write your two different equations. Okay, so what we mean by that is we would be happy if that n plus 9 equals 14. So write that without the absolute values. I'd be happy if n plus 9 equals 14. Or I'd also be happy if that n plus 9 equal the negative 14. And the reason why is because the absolute value of a negative 14 is also a positive 14. So you write your two different cases. Solve those two different equations, minus the 9 over n is equal to 5, minus the 9 over n is equal to a negative 23. There's my two answers. All finished. Solving an absolute value inequality is really similar. The first few steps are the same. In fact, we're actually going to add one new step, and that is we're going to write that absolute value with an equal sign. So don't worry about the greater than or less than. Just write it with the equal sign and solve that first, and then we'll do the inequality part second. So I'm just going to start by minusing that 9 over. That'd be 0. So yeah, the absolute value of n minus 6 equals 1. Write your two different equations. N minus 6 equals 1. N minus 6 equals negative 1. Add the 6 over on this one. So you get 7. Oops, sorry about that. So n would equal 7. And then over here, add the 6 over, so n would equal 5. Okay, put those two numbers on the number line. This one had an equal sign, so at 5 and 7, I'm going to put a closed dot at both. Next thing is decide which way it's shading. Usually if it's a greater than, it's going to be going out. Remember, the answers will either be out from those 2 points or it will be between those 2 points. The way we're going to find out is just by checking. So pick a number that's either between or on the outside. We could put, for example, 2. 2 is on the outside. So if I plug 2 in, I get the absolute value of 2 minus 6 plus 9 is greater than 10. Well, 2 minus 6 is a negative 4, but the absolute value of negative 4 is positive 4. So I end up with 4 plus 9 is 13. Is 13 greater than 10? It is, so that's a true statement. So that means 2 work, so I've got to shade outside. The way you write the answer, we're just going to use interval notation here, is we'd say it starts at negative infinity and goes to 5. And then it starts again at 7 and goes to infinity using interval notation. The second to last type of equation was a radical equation. Ooh, but this is not a radical equation. I'm sorry, let me get this one out of the way, and we'll do a different one. If you have a radical equation, a radical is a root. So here's the example. You could have 5 minus 2 square root of x plus 3 is equal to, oh boy, now I'm on the spot here. I've got to make sure I figure this out. Let's go 13. Hopefully this works out okay. We'll try it. All right. So first thing, just like the absolute value equation, is get that radical by itself. So I'm going to minus a 5 over first. So I get negative 2 square root of x plus 3 equals 8. Divide by negative 2. I get the square root of x plus 3 equals negative 4. So that's your first step, is to get that radical by itself. The second step is you got to get rid of the square root. So to get rid of the square root, we square both sides. So that would give me, I'm going to come up over here, x plus 3 equals negative 4 squared, which is 16. Okay, now let's get x by itself. So we're going to minus the 3 over. X equals 13. Now, one thing to be really careful with is when you solve a radical equation is sometimes you can get what's called extraneous solutions. Okay, all that means, extraneous solutions, means that you did everything right, but the answer doesn't work. So you have to check your answers on these. So let's check this. Plug it back in. I have 5 minus 2 times square root of 13 plus 3 equals, and the question is that really equal 13? So let's try it. 13 plus 3 is 16. Square root of 16 is 4. 4 times 2 is 8. So 4 minus 8 equals 13. 5 minus 8. 5 minus 8 is a negative 3. Hey, that doesn't equal 13. So we come back up here. This is not a solution. It was the only possible solution. So if it doesn't work, we're going to say no solution. So steps, get the radical by itself. Once you do, square both sides, solve the equation, but you have to check the answer. Okay, that's required. That has to happen every time because you can get those extraneous or false solutions. All right, last type we did was rational equations. This was everybody's favorites, right? So remember with rational equations, you have to come up with an LCD. The LCD is the least common denominator. Before you do that, make sure everything is factored. So we're going to factor the x minus 5. Well, it doesn't factor. So just put it in parentheses to show that it's a factor by itself. This one has an x plus 4. It's not going to factor. This one does factor. So let's try it. What do we times together to get x squared? What do we times together to get negative 20? That adds up to be a negative 1. So negative 1 and 20, negative 2 and 10, negative 4 and 5. So the one that works is, well, that would be a positive 1. So let's switch those. So it'd be a plus 4 minus 5. Okay, with the LCD, you have to include all the different factors. We only have 2 different factors. The 2 different factors are x plus 4 or x minus 5. So let's include them both. I need the x plus 4 and the x minus 5. Okay, we're going to take this equation then and multiply. I'm going to rewrite it, but we're going to multiply both sides by that least common denominator. And what should happen is that all those fractions should cancel out and leave me with an equation that doesn't have fractions anymore. So let's multiply both sides by that LCD. When you do this, focus on what's going to cancel. So when I multiply over to there, the x minus 5 is going to cancel with that x minus 5. That would leave me with 4 times x plus 4. Okay, distribute it through here. On this one, the x plus 4 cancels with that x plus 4. So I'm left with 1 times x minus 5 plus. This one works out really nice because both of those cancel with both of those. It'll just leave me with a 4. So that's usually the step we get stuck on. That's the one that if we're going to have a problem with these, usually that's where we have it. Once you're past there, this is just a matter of solving a linear equation. So let's solve this linear equation. Times through by your 4x plus 16 equals times through by your 1, x minus 5 plus 4. We could simplify the right side there. Minus 5 plus 4 would be a minus 1. Get rid of the x's off one of the sides, so I'm going to minus x. So 4x minus 1x would be 3x plus 16 equals negative 1. Minus 16 over. I might come up over here. We get 3x equals negative 17. That was a bad spot I chose. I divide by 3. So my answer comes out to be x equals negative 17 thirds. And that will happen a lot, that you'll end up with a fraction or a decimal. And that's okay, so don't let that bother you. So those are tricky, but the steps, find your LCD, factor, make sure your denominators are factored and find your LCD. And then multiply both sides of the equation by that LCD. And again, all your fractions in the equation should cancel out and leave it in the equation that doesn't have them. Then you just go through the steps of solving them like we normally would, just a normal linear equation. Hopefully that's helpful. It was really quick, but if you need more specifics, there's a certain type of problem, make sure you go back to Canvas. It's all posted on there, and you can choose, you can watch the video that goes through multiple examples of each one of these. Then let me know if you have questions. And let's just make sure we're all ready for that test. All right. Thanks, guys. Appreciate it.